let's continue with our overview of SQL. And we look at the concrete example, right, of this SQL database, Chinook. Right, it's used for learning, but of course it's actually a pretty decent average size database. Again, with non-trivial number of tables. And again, notice in this picture, or maybe you can see this here even better. Where's my picture here, right? You see these little keys, right? So these here are primary keys for each table. Actually, here, of course, actually not necessarily primary. Actually, so there's concept of primary keys, which means it's a unique identifier for a row of data in a particular table. And then you have foreign keys, and foreign keys are used to link data in some table to another table, right? So this is very, very typical. It's like a core feature of a relational database, this use of primary keys and foreign keys, right? So this lets us link the tables together, right? So we will use that to create queries, to join, to use joins, right? To generate our views, right? So primary keys, it's a unique identifier, right? It has to be unique, right? It could be numeric, 1, 2, 3, 4, 5. But sometimes they use, of course, we can use unique, hash values, things like that as well are used. But of course, it's very difficult to use numbers. So foreign keys refers. You could have a table which has multiple foreign keys from different other tables. That's completely fine, right? So normalization. There are forms of normalization. How much of duplication happens? How the keys are dependent, right? But again, let's see this in action. So SQlite, it's again, I told you it's my favorite database because it's so ubiquitous. I can't pronounce the name. It's everywhere, right? But again, so popular. And I last I checked, 280, yeah, 280 terabytes. Maybe it's now even more. Let's double check. Now, size, right? You can run really large applications on SQlite, right? It's kind of interesting. It has actually, it's a single file. Basically, you have a single file with DB extension. Yeah, 280 terabytes, right? Yes. There's some people have done actually some interesting hacks with it, right? So, there are some limitations about SQlite, whether you want to use it or not. It is unlimited number of simultaneous readers, but you can only have one writer at a time. Most of the time, it's no problem. You have a queue, right? You write quickly and move on, right? Because what we have, of course, in databases, SQL databases, you have a way of managing these locks of write protection, basically, right? If you need higher concurrency, right? In a database, you don't really want to worry about this concurrency, this issue of multiple players, players, or let's say banking application, people changing their account balance all at the same time, right? You want things to happen atomically, right? You have two accounts, right, in a bank. You don't want to, hey, add 5,000 to one account, at the same time take 5,000 from other account. You don't want those things to happen, that you add 5,000 euros to one account, and then the application, your query, your business query drops, stops, and you added 5,000 euros, right? And you didn't take 5,000 off, right, the other place, right? You want the atomicity, right? Meaning it either happens or does not happen, right? It's one of the core requirements you want, actually, right? So it's possible again, right? Again, SQlite again does not support multiple user names, administration levels, right? For multiple, access levels. That's of course, then you have Oracle, MariaDB, Microsoft SQL, and so on. If you have those requirements, but as far as basic syntax, it's completely fine, right? And it can be used for quite a few applications. Okay, so we'll look at this, and we will use Python to do some basic queries. There's an interface built in. Again, you could use, of course, I would recommend some online or some desktop tools. Again, I really like this one here, DB Weaver. It's open source, right? Community. Supports all kinds of databases, right? SQL Server, Postgres, you need it. If you have a commercial version, it also supports all the cloud-based ones and also NoSQL databases, right? but you don't have to pay, right? I don't know how much the commercial one costs, probably like 300 bucks or 400 bucks, euros. I forget now, but you don't need to buy license. How much was it? 250 yearly? No, you don't need it. You don't need it. You can use it for free, basically. Okay, but let's look at this again in terms of Python. So in our repository we have a Chinook database, and let's get some results. So let's get some tables. So it's very typical, depending on your language, that you use something cursor, right? It's just a name, meaning you have create a connection, right? If you had another database, maybe let's make it a little bigger, right? You need also maybe username and password because you have multiple levels of success. Here, SQlite assumes that if you can read this, if you have access to DB, then you are authorized user. You don't need, obviously you have the data, right? So there's no need for password username, right? So we skip on that part. On the connection, cursor, and then we have a select name from SQlite master, so it's a particular data table. So we're using our database to see what kind of tables we have. And then we're going to execute the statement, and we're going to get fetch all results, right? And we are going to unpack this list of results and see what kind of tables we have. Let's see if this works. Last time we checked, it worked. Again, we'll see if we need to fix up anything. Yeah, so we can see, this is how we can see the tables. How many we have? 3, 3, 3, there's actually 13. So the SQlite sequence and SQlite stat1, those apparently are not part of here. Maybe I made some tables. Maybe this is like some statistics, and this is maybe something else, or maybe these are internal tables for actual database use, right, which you don't use generally, right? So let's look at the syntax again. So select, so it's a way of reading. We said, okay, I want name from SQlite master. So there's table for SQlite master, special table, where type is the table holding tables, basically. So it does not include itself in this particular case. All right, but let's look at the most popular type of query. Select star, what does that mean? This means we want to select all rows, all columns from a particular table. But in this particular case, we are already learning some syntax. So this part here, right, would give us pretty large amount of artists. However, I don't want to see all artists, right? I want only artists whose name starts with the letter C, right? And we want order by the name, and we want limit number 25, right? And also, we don't, by the way, I'm using something called fetch all method, meaning I'm fetching all the results. Oftentimes, if you're doing a large query, you do not want to fetch all the results. You want one by one. But for now, we're learning it all. So let's take a look what we have, right? So this is C, K, Calexio, Charles, Z, Charles Brown, Chicago, right? Christina Aguilera, right? And so on, right? So we got the first 20. So we saw some, this is one way of, we saw like 3-4 things that we can do in SQL, right? So let's see what happens actually if we did this query without without anything, right? What would happen? Let's try it. Let's try this again. Maybe I do it, right? Let's do this. Maybe I'll do it first, right? Let's get all artists from the database into a list of, right? So our query equals select all from artists, right? Course execute query and results fetch all, and should be, right? Fetch all should give us, right? So now how many we have? How many results? Let's check print length results. Print first 5, right? Let's take a look. So yes, so not surprisingly we start with AC/DC, right? Except Aerosmith, Alanis Morissette, Alice in Chains, right? You might know some of these groups, maybe you don't, right? So again, let's get first 15, right? So I will actually print them like this as a separator, right? Yeah. So we can see, yeah, Black Sabbath, right? Right. Some of the names I don't even know, right? So these are actual names of the artist, Right, I think body count is iced tea. Right, so that's 275. So, of course, this was, so we have, of course, right, in a, in a large database, we might not actually want to get all results like this, right? It is typical to add some limitations. Let me query. Of course, right, so we could, yeah, right. Now we could use Python to fill for process results, but we can also use SQL because SQL supports, of course, these typical operations, right? Will be for reading. So this is a reading phase, right? We are reading some data, right? So this other, so more a little bit more complex basic query, right? Some SQL tools. Let me add some queries. Yeah. Queries in Python. All right. Basic table information. And select all rows from a table, right? So this is, of course, the most popular. Again, you would use something like SQlite online, right? You would use that, for example. Let me see what kind of plugins we have here. Let me see if I can add some plugins, right? So what do we have here? What do we need to update? Oh, GitHub, Copilot Chat, no pylons. Let's see SQL. Let's see what kind of updates we have. Server, SQL bindings, SQL tool, SQlite. Let's see, 3.3 million, but very bad feedback. Let's see, maybe it's kind of nice. Okay, let's take a look how it works. Maybe we can install this plugin. We can run it, and we could do some ID. Yeah, we could do something. Maybe we have some tables. I don't know. It looks very popular, right? But why is it so bad? People don't like it. I wouldn't mind installing. Not the easiest tool. It does not work. Okay, that does not right. Yeah. Yeah, some people say it works, doesn't work for some, right? Kind of not so sure. Prettier VS Code, SQL files. I don't know. We could try, right? Again, I use something called SQlite. There's also quick and dirty SQlite online. I believe it's this. Yeah. Basically, you load the database, right, directly here, and then you can make your queries, basically, right? So, I hope there's pricing now. Used to be free. What's up with that? Right. Yeah. But maybe there's pricing. There shouldn't be. Oh, if you want to store something, right? Maybe not the right address, right? Let me see if we can add database. Open SQlite DB. So I would need to have a local version. Let me download quickly my database. Where's my database? Oh, cancel. Let me see here. Where's my extensions here? Yeah, I don't want this one. I guess I'm not going to do it. I'm going to just restart it. SQL. Start tools. So what I'll do is I'll download this to more machine, right? Allow, download. And while I'm restarting my reload Windows, right? While I'm restarting this code space, we can use this online tool to add database. Open SQL database, and we have downloads. Chinook, right? So we can open it up. We can see now tables. I can make this a little bit bigger, maybe. Yeah, I can make this bigger. We have our tables, right? And of course, we can run a query, right? Select all from artists, right? And notice how, again, even this very basic ID will give you some basic hints. It tells you, okay, table, artist table, let's do that, right? Let's see all tables, right? And of course, we want to run it. And we see again accept, right, Bruce Dickinson and so on. So it's very typical to do things like limit 10, right? We only have the first 10, right? How about this? Very typical is to have something where name, right, is exactly, so that's the name column. What's interesting about SQL, it is case insensitive, right? So these column names actually, you can divide, I can say name, right? Or name, right? Or name, right? Small, right? And I could do like, so it's like fuzzy matching. I'll do be something, right? So be something. Let's take a look. First 10 of B, right? No, where's my syntax? My syntax. Like, no, I did correctly. You're right. Of course, because artists. So I should probably say artist's name, right? Artist's name, right? Okay, so maybe it wants this. Let's take a look. No such column. I wonder. There's the B. Did I do a typing here? Oh, maybe I had to do single. I do it. No, this looks okay. Interesting. Why did I do a mistake somewhere? That's under. Looks okay to me. Where artist name equals accept, right? This doesn't work either. So there's something here. There's some error here. Yeah. In maybe this online database only wants. Yeah, it only wants this one. Okay, I think so. Yeah, it doesn't like double quotes. Yeah. Okay. Yeah. All right. Yeah. So that's the thing. So we need to actually do single quotes for this online version. So this is one of those things with multiple database, this SQL. Yeah, so now it works, right? We see backbeat, Bruce, but it's not ordered, right? So what we want probably, we want to order things like order by name, right? So name, right? Order. We could order by something else, but order by name here is really basic, right? Right? And again, I could do this. This should work as well. Let's see if this works. Yeah, it works, right? So note how it works fine also without any non-case. It's not case sensitive. Again, it's for historical reasons, right? So very typical to have some specific filter. So like is a fuzzy match. I should immediately mention that basic SQL, unless you have some plugins, some extensions, some extra modifications, it's not very good for pure string search. For this fuzzy search, you probably want some extra engine, something like Elasticsearch. There are more specific string text search engines, right? Basic SQL, right, relational database, right, by itself, like a default installation, is usually not well suited for like a complicated regex searching, right? It's not really good for that, but there are modifications for databases, for relational databases, which can do it, right? But out of the box, usually it's not a good idea, right? I mean, you can do it, but it's not usually best optimized for that, right? So this is sort of fuzzy match, so we can say, okay, B, BE, right? And of course, you only have 5, Berliner, Bibel, and Ben Harper. I don't know who these guys are, but you can. Right, so, again, so notice in SQL queries, so these SQL read queries, maybe I'll have information here, so basic, this is actually we have time, so this is actually kind of short last time. So there's official documentation, which is fine, but there's really nice SQL tutorial, right? This one here, right? Show you syntax of a query. No, not this. No, not this. Nah, that's not. It's okay, but it's not great. But this one here, I meant. Yeah, this one here. This one's pretty good, right? So consent again. Look, I had consent. So select. Look at this query. So this will show you. There should be a little. Let me show me the picture of full select syntax query. Am I in the right place? No, I'm in the right place. But it's, oh yeah, so this is what I want to show you. So this is a full syntax, right? So full syntax. Again, so obviously if you're doing select, you need of course select, right? Pretty much everything else is optional, right? You need to tell what do you want to select, and then possibly you might want to join things together, right? You want to join table on some condition, right? So, because if you don't join tables, what will happen? You will have, basically, without a join, you'll have a sort of Cartesian everything versus everything, right? Which is probably what you don't want, probably, right? So I'll show you what happens if you don't, right? So let's do some queries without joins, and that will probably not what you want, but we can try it. So this one here, full select syntax. Full. Yeah, this is full syntax. Right. Now, is a picture? Maybe I can do a picture for it. I wonder. Yeah, is it picture? Save as no, it's a web page. No, it's actually it's actually a clippy. So yeah, so we can order by. We learn what else? Do we learn limit and where. So these are already a good thing we can do. What else can we add? We can do change the order. We can do descending, right? This, I think descending means we'll start with the reverse order. Let's do B, right? So let's do on. You see, we start with BU, not BA, right? We go the other way, right? We go the other way. We start from the end, right? So if I don't have anything, this, right? If I have comment, can I do a comment? Commenting was, I believe, was this? I forget now. No. What was the comment? What was the comment in SQL syntax? I'm already forgetting. What was the comment? SQL comment was two dashes. Sorry, two dashes. Right. So what I'll do is I'll comment this out. Right. It's all grayed out. Right. So this means what do we expect our artists? We probably get somebody like ZZ Top as the first one. Right. Yeah. Yo-Yo Ma. There's no ZZ Top. What kind of playlist is this? Right. There's Yo-Yo Ma, White Snake. I don't know. Right. Right. So this guy's pretty good. Right. That Algerian guy. Right. So yeah. Okay, so ascending, descending, so it's built-in sorting, of course, and log n, nothing, you don't have to sort. Basically, there are many basic data manipulation tasks you can do in SQL, or of course, what happens, of course, oftentimes you can do it afterwards in your language, of course, you can do that as well, right? So it's, of course, very optimized for most of these basic things. So since we have time, so since maybe there are no questions, since you guys already have some experience, let's do some joins, right? So yes.
Remind me in the previous where you showed all the solid forms.
Yeah.
In the
yeah. See this one, yeah.
Yeah. Could you remind me what offset?
Okay. Yeah. So okay. Yes. So let's say you have a shopping site like, I don't know, X20, 220 LV, or I don't know, or what's the name? Any shopping site, right? You have a page results like Amazon.com, right? And so you make a query, your application makes a query to the database, and you get a list of products, right? So to go to the next page, basically, your query is going to be offset by something, basically, right? So you're getting results. So not the first 10, but let's say you want to get 15 results, but you add offset of something, so you skip some results. So that's what all it is, really, right? So it's used very widely for paginations, basically, right? You have a huge, instead of showing a single page with all the results, right? This lets you do pagination. And I'm showing you what it can be used for, right? Very popular type of modification. So I'll show you this actually, right? Here, so let me add offset, right? So offset comes before limit, or actually, it might not matter, but usually the order matters. I mean, it might complain. So let's say offset 5, right? So what do we see? So we should expect that Wilhelm should be first, right? We'll skip the first 5, right? Let's see if that's the case. It is, yeah? So did everybody get that, right? Yeah. So we skip some results, right? Again, because I can skip like this, since I know I can skip like 260, right? So I could do that, right? And we have, A, because I know 275, right? So we almost to the beginning, right? Almost to the beginning, right? So because I ordered, notice I ordered first, and then I limit, and then I offset, right? So the order of these things actually matters. In fact, you can't, and again, you can't, if I move this around, this won't work, right? If I do this, this will be a syntax error most likely, almost certainly, you see? It's a syntax error. I have to follow the order. You start for select, right? And pretty much everything else is optional. These things are optional. I mean, I could comment these out. However, the way you put them, right, you have to look at this cheat sheet, right? How which comes first. So let's explore joins a little bit, right? So I think next lecture we'll do more, but I think next lecture we'll do a murder mystery. All right, SQL murder mystery. If you've not done that one, that should be fun. So, but let's explore these. Let's explore some joins, right? So basic idea is you want to join some tables together because we have results. If you check, let's check tracks, right? Let's take all from the artists. Let's some tracks, right? From tracks, I see it tells you, right? Also, it's very typical to have a short name as T, for example, right? So this is a shortcut. It's like an alias, right? Very typical, right? So I could do this order by T name, right? Let's do limit 10, right? So this will be the last 10 tracks, right? Let's do. Is there a name? I don't know. Maybe there's an error. What's up with this? Maybe order by T name. Let me see what happens if I don't do anything. What about this one? Okay, yeah. I guess there's no name. Or maybe, because artists. I don't have artists, right? Yeah. T, no, tracks as T. It should have ordered by T. I don't know, maybe they had too many tracks, I wonder, right? But anyways, right, so we have these tracks, but notice something here, right? If I check this, right, all right, for all those about to rock, balls to the wall, fast as the shark, this certainly looks like AC/DC track, right? Those who know the AC/DC, right? So, album ID, but however, notice, so this is album ID, right? These are all links, basically think of these as links, relations to other tables. So these are so-called foreign keys. Foreign keys to other, in this case we have a nice cheat sheet, album ID. So obviously here the table will be called album or albums, right? So there's also some flame bars, whether should tables be called plural or singular. Usually I think it makes sense to have it plural, because that's what you have multiple rows, right? But it could be singular. It doesn't, I mean, it's just up to you how you make your tables, right? But so this idea, this is okay. If you want to know who actually, what kind of album it is, right? This track is from, right? We will need to join it with an albums, right here, right? And it has an album, but that's not all. Albums don't have artists either. Artists are just a link to artist ID, a relation to artist ID. So let's do this query, right? Let's see if I can do this by hand. So what I will do this, right? I'm going to limit 10. So only first 10. So join, notice the syntax, right? So I'll do this by hand, join table, or maybe I guess I'm lazy. Let AI do it since I'm lazy, right? So I hopefully should do it, right? So joining tables. I want to do this. Control X. Let me see this. Joining tables. Right. Yeah. Usually relational. This is done using. It will often involve primary foreign keys. Foreign keys is link. Okay, so let's take a look. So let's get the list of tracks on their not composers, but on their album names. Right. So notice this query, right? Limit 25, right? So we'll get the first 25, right? And we'll also fetch. Again, notice this Python way result. We're not using any library, by the way, right? So I'll fit all 25, right? So this what's wrong with the query? Yeah, name cursor. Oh, did I miss? I think it's called the cursors. Oh, what happened here? Cursor execute. It should have worked, or did I? Oh, I didn't reload it. Oh, sorry. Yeah, I didn't load the database, right? Because remember we restarted. Yeah, we need to connect, right? Let me connect. Yeah, I didn't have cursor on. Right, so let's do it again. Yeah, so notice here, right? So, what do we select? We select tracks table, albums title from tracks, albums. So, oftentimes here, let me modify this query a little bit, right? So, since we are lazy, right, you don't say tracks name, albums title all the time. So, we'll do is this. It's very typical. Do this. Look at this here. From T A, right? Tracks as T, right? T on albums A. Come on, AI, do your thing, right? Albums. Right. So this again. So what is it? Why do we do this? It's very typical in databases to be lazy, right? Let's see if this works. And now it works the same. So what do we gain? So note also, note how we used aliases. Yeah, I wouldn't say more readable. I would say to make query shorter, right? Possibly you could argue we made less or more readable, right? But it is very typical. It is very typical to use alias in SQL, right? So depending, some dialects require, some SQL dialects require to, yeah. So maybe sometimes you have to use as. Between here there's as. This is not required in SQlite, but some you have, right? So this is not required in this case, but it's allowed, right? So again, we are lazy. We skip things we don't want to write, right? It depends on your dialect, right? Yeah. So, okay. But everybody's clear on this query. Well, is everybody clear on this query? Well, what happened? So why did it work? Right. So this is actually kind of important point. For today, it's like the main point for today. For joins, it works because we have album ID, right? So notice here, this is apparently Angus Young, composer. We know of Angus Young. Well, I believe he is AC/DC, right? One of the guys, right? So that's kind of, so this could also been a foreign key, by the way, right? In this particular database, it's not a foreign key, right? There's no composers table. Composer put directly, right? But albums, right? So you can see this foreign key. It's one-to-many relationship, right? Because multiple songs can be on the same album, right? You agree, right? Makes sense, right? So we can get this information out. So we can check, right? For those who are about to rock, we salute you. So the question now is, how do we get the actual artist? We got the album. Yeah, we know it's AC/DC, but how do we make it sure, right? Let's do that. Let's do that. Let's join one more table, right? This will be the last thing we do today, right? Let's join artists tracks and get full information for first 10 tracks. So select AR name. So in this case, of course, notice, right? We have to right? Yeah, let's unpack the list. Right, so limit 10, right? So again, in this SQlite, this basic library, you have basically a list and tuples, right? You might want, of course, consider something more serious library, because there's one big minus to this. In a way, if you know your SQL decently, and of course you have AAC, so notice here how it works. So we got a name. So this is artist name, right? So this is the album, and this is the actual song. So how about we can also get how long is the track? composer unit price. Why not? Right? So why do we know composer unit price? Because if we check here, tracks, right? You see it here, yeah. You could check, right? You can see all the columns, right? Notice how there's an NVAR chart, so it's kind of like a string with specific number of maximum. There's numeric, there's integers, right? Numeric meaning it's actually floating point, right? So they're different, that kind of similar to what regular programming language use, but there's some other advanced data types and some more fuller SQL databases, but basic data types are there, basically, right? So, what else we want? So how long it is? Milliseconds, right? So let's take a look. Also, I'm getting composer. Let's take a look. Yeah, so we see it's a different composers, right? We see also that these are all. Let's get first 15, right? Accept, right? Accept actually is Bowserval. Sorry. Yeah, I don't know my heavy metal that well as I thought. Actually, I do, but that's yeah. So notice also all the prices are. So we have the pricing information. Everything is there, right? So how about length? Let's get also. Let's get length of track. Length of the track. It means milliseconds, right? All right. So this is we'll need this, right? So notice this is so now you can see why we need for SQL it's so common to use alias. If you want specific column name, it gets tiresome very quickly to write the full table name. You know, tracks, album, artist. So we use these shortcuts, right? Because we have to refer to if you are joining something, right? You need to refer to specific column. So again, so why does this work? Again, let's check our table, right? So tracks, right, have a particular ID which is unique. We're not using it in this case, right? We have a name, right? We have the column, we have composer, and we have the price. This is already built in the track. However, the album, right, is just an integer. This is just basically, you can think of it as a pointer or a reference or a link, really, in terms of normal programming languages, right? It links to the album. And the albums are also kind of very bare bones. They include only the title of the album and actually the artist. Of course, you can see that this artist is also very bare bones. You could imagine that this could have an address or maybe a phone number of the artist and so on if you are a stalker or something, right? So, you know, or favorites, you know, what kind of dish they like and so on, right? And of course, it could be another table of favorite dishes, and you could make this table, add them extra tables, right? But for now, this just has the name of the artist, right? Or the group, actually, in this case, right? And how many members and so on, right? So, now, this is this is the length in milliseconds, right? And we want to actually, what we could do is this. Let's do as seconds, right? Let's do this. 1,000, right? In seconds, right? Right? So we can see in seconds, right? So we can see the length in seconds. Of course, we get also in, however we get in minutes. We divide by 60 again, right? Times 60, right? And we will get the length in minutes, right? Let's do that. Let's see if this happens. Yeah, no, that didn't work as well. Didn't want this one. Did not work. Maybe I think I need to put some. I need to put them. Let's take a look again. Yeah, I think I need to 60. I think I need to do this if I have to remember correctly. Yeah. Yeah, but notice this also, it is in only in this particular case, it is actually integer here. We probably don't want that, right? We want probably in seconds, but we might need to cast, yeah, let's do that. Yeah, maybe this one. Let's take a look. Oh yeah. This will work. Oldest trick in the book, right? Let's take a look if this works. Yeah, this works. Because we probably have the function round, probably, right? We could do a round. I mean, we can go create. I mean, we can do some math in SQL. I mean, it supports basically math. What we have not covered yet is branching. I mean, if you want to think, there is a way, of course, branching in SQL, right? It's not, of course, needed in normal queries. We'll need to do some selective queries that might be used, right? So, but again, hopefully you guys can follow the idea of these joins, because that's a fundamental part of SQL. Right, so does anybody have a question about how joins work? Or you guys pretty much all kind of know, kind of figure out, kind of makes sense, right? Because we basically have a reference, right? Again, when we're doing a pool, right, when it joins, right, we have a reference to this album, right? We have these multiple tables, right? We can create a new, basically we call them views, basically, right? And here we show it to the screen, which includes all this extra information, because this information is present, because this particular ID uniquely identifies which album this song came from, right? So this album ID, right? And then we can join it, and then we have, in fact, we don't need to display this album ID, right, in this case, right? We could, right? Because again, in this case, of course, this matches. So if it didn't, but if you didn't have this condition, then we get something really silly. Or we have albums, you know, we have, it would, the database engine without this join restriction, it would match the name to all possible artists. So you have a table, you know, the song for those about to rock you, but it would be attributed to all the artists without restriction, right? It would be silly, right? But it's that if you don't have this correct join condition, right? But again, it's usually it is a foreign key, right? So it's a foreign key on tracks, but it's a primary key on album. Here, the artist, on the artist table, it's a primary key. Here, it is a foreign key. So this is a very simple type of join, but it's double join. So one thing about joins, those who have worked with SQL databases, what's the problem? Well, if you have a big database, joins, of course, it's a set operation, right? It's an algebra joining things together. They can get slow if you have a big database and you have multiple joins, right? It can get slowed down, right? Conditions. So there are some tricks to get around it. You can do indexing, right? Basically prefetch, or you can have creative use. But we'll see some of those next week. I mean, not on Thursday, right? We meet on Thursday, right? Yeah. So Thursday we will do a little, I think probably murder mystery, I think, right? I think. Yeah, so we'll do some SQL exploration, right? And again, usually this basics, people get tired of writing this, the minus for this. So why is this approach kind of not very good? I mean, all languages will support these libraries. However, what's the big downside for this type of approach of writing queries? Well, I have AI to help me here, but basically I don't get syntax assistance. If I make a typo here, right, I only see it when I run the query, right? So I get feedback slower, right, only later, right? So that's a problem. So that's why usually all kinds of tools, right, like these, right, they will give you hints, give you hints what to write, basically, right? Of course, with LLMs it gets easier. All right, so see you guys on Thursday. Some of you I'll see you soon. What do you have? Do you have something else right now for the rest of you? No? Okay, excellent.